This 0 to GWAS tutorial will walk you through a GWAS analysis on the AnVIL platform. This tutorial leverages material originally created for an ASHG 2019 workshop to analyze publicly available 1000 genomes genotype data along with simulated phenotype data. The main objectives of this tutorial are to show you how to clone a workspace, run a Jupyter notebook, run a batch analysis, and finally to shut everything down. Clone workspace. The first thing we will do is clone an existing workspace. This will create a workspace for you to conduct your analysis with all of the necessary files and configuration parameters pre-populated. Starting at the AnVIL homepage, click on View Workspaces. Search for GWAS by typing GWAS into the search box at the top. Click on the Public tab to reveal workspaces that are publicly available. Today we will work with a workspace that was created for a 2019 ASHG workshop. Find the row that corresponds to 2019 ASHG reproducible GWAS version 2 and click on the 3 vertical dots on the right. After the pop-up menu appears, click on Clone to create a working copy in your billing project. Click on the Billing Project drop-down menu and select the billing project you wish to use. Afterwards, click on Clone Workspace. Voila! You've successfully cloned a workspace on Terra. The landing page for each workspace is a dashboard where you can keep high-level summary information about this particular work and access important information. For example, the description of this workspace indicates that you will be analyzing publicly available 1000 genomes genotype data along with simulated phenotype data. Additionally, the lower right-hand corner contains a link to the underlying Google storage bucket associated with this workspace. Click on the Data tab to see what data tables are present in this workspace. Click on Sample to see simulated phenotypic data for 2,504 individuals from the 1000 Genomes project. Scroll left and right through this table to see what simulated phenotypes are present. Run Jupyter Notebook. Next, we will use this workspace to interactively analyze data using a Jupyter Notebook. These notebooks can be used to not only analyze data but also configure the workspace for batch analysis workflows. Click on the Notebooks tab to show what Jupyter notebooks are present in this workspace. These two, GWAS Initial Analysis Completed and GWAS Initial Analysis Cleared, were copied from the original workspace that you cloned. Click on the cleared version which contains all of the commands but none of the results. Initially, you will see read-only preview of the Jupyter Notebook. This read-only status is indicated in the upper left-hand corner. While you cannot run any commands, you can scroll through the commands and any documentation that is present. Scroll down slightly to the section titled Set up your notebook. This section indicates what notebook runtime environment we need to create to successfully run all of the commands in this notebook. Once you have found this section, click on the gear icon in the upper right-hand corner. Next, click on the Environment drop-down menu. Select Hail, which will provide the software required to speed up your analysis by spreading it across multiple compute nodes using Apache Spark. Next, in the Compute Power section, click on the Profile drop-down menu and select Custom. Update the CPUs to 8, memory to 30, and disk size to 100. Next, click on the Runtime Type drop-down menu and select Configure as Spark Cluster. Update the workers to 4. This setting in particular is what will allow you to spread your analysis across multiple compute nodes. Before clicking on Create, note the cost estimate, which in this case shows $1.42 per hour. At the end of each analysis, be sure to pause or delete any runtimes that you do not wish to continue paying this hourly charge. We will do that together at the end of this tutorial. After clicking on Create, the upper right-hand corner will display the status of your notebook runtime. In this case, the compute resources you requests are still being created. This may take a few minutes. Once the upper right-hand corner reports running, you can click on the Edit button. Shown here is the standard Jupyter Notebook interface where you can run commands. For the purpose of this tutorial, we will run all of the commands. You can come back later and explore each of these sections in more detail. First, click on the Cell menu. Then click on Run All. You can watch the progress of this analysis by paying attention to the left-hand table of contents. Sections that are still in queue are highlighted in red. Section 6.2 in one example of an analysis that leverages the HAIL framework to speed up analysis by spreading it across multiple compute nodes. Section 7.2 demonstrates how you can send results from this analysis to the workspace data table. Your analysis is complete once Section 8 finishes and is no longer red. Click on the X in the upper right-hand corner to return to your workspace. Note that this will not suspend or delete your notebook runtime and you will still continue to incur charges. Again, we will shut this down together at the end. Run workflow. Now, we will use this workspace to run a batch analysis workflow that identifies variants associated with a phenotype of interest. Click on the Workflows tab to show what workflows have already been imported into this workspace. We will use the Genesis GWAS workflow from DocStore, which can take advantage of cloud resources. In this example, analysis will be spread across 22 different compute nodes to search in parallel for associated variants. Click on the Genesis GWAS workflow to begin configuring your analysis. This screen is where you can configure various input and output parameters that have been exposed by the workflow author. As we cloned this workspace, the input and output parameters have been pre-configured to sensible values. Importantly, the phenotype that will be analyzed is the synthetic BMI data. The only other thing we need to do before running our analysis is to indicate which sample set we wish to analyze. Click on Select Data. Currently, this workspace contains only one sample set to analyze. Mark the checkbox on the left-hand side and then click on OK. Now click on Run Analysis. Confirm that you want to launch this analysis. You will see a workflow status screen in your job history showing the status of your analysis. Initially, your analysis will be marked as queued, meaning that it has not yet started. After a few moments, refresh your screen. When the status has changed to Submitted, you will now have an option to view more details about your analysis. Click on the View link in the left-hand column. The Job Manager website provides detailed information about your analysis, including what stage it is at, any errors that may have occurred, and importantly, links to analysis outputs. A set of circling arrows indicates that a particular task is running. Your analysis is done once every task completes successfully. Back at the workflow status screen in your job history, you should also see a succeeded status indicator if all goes well. This Genesis GWAS workflow also creates links to your analysis output in the data table. Click on the Data tab and then click on Sample Set. Scroll to the right to see both input parameters as well as links to output files. Click on the entry in the GWAS plots column. Here you will see some summary statistics including a Manhattan plot. In this case, variants associated with BMI are found on chromosomes 2, 6, 16, and 18. Scrolling all the way to the right shows a link to the top variants identified during this GWAS analysis. Shut down. Finally, before ending this tutorial, we will delete all components that may incur charges. This includes actively running compute nodes as well as Google buckets storing data. Note that in the upper right-hand corner we still have a notebook runtime that we created to run our Jupyter notebook that costs $1.42 per hour. To delete this runtime, first click on the gear icon in the upper right-hand corner. Now click on Delete Runtime. Finally, confirm that you wish to delete your Jupyter notebook runtime. Be warned that any data that you have not transferred to your workspace or other backup location will be lost. Confirm that the upper right-hand corner shows none rather than an hourly charge. The last thing we need to delete is this workspace. Click on the 3 vertical dots. Now click on Delete Workspace. Confirm that you wish to delete your workspace. Again, be warned that any data that you have not transferred elsewhere will be lost. In this tutorial, you cloned a workspace, ran a Jupyter notebook, ran a batch analysis, and shut everything down. From here, you can learn how to bring your own data, analyze using RStudio and Bioconductor, or run a different analysis.